average life or mean life, which can be said that average life or a mean life of a radioactive substance. Means in earlier video we discussed about the half life. Half life means the number of atoms, the time for in which the disintegration, the number of atoms to become half of its actual value, then that is called as half life period of atoms, of a radioactive substance. Then now we are going to discuss about average life or mean life. Simply we can say that the average value of some of group of values, then we can say that the sum of the individual values by total values, total present values. So that case of the ratio of the sum of lives of all the individual atoms, means the number of atoms are present at that place before it is disintegration in a radioactive substance, the number of atoms are there. So that the ratio of sum of the lives of all individual atoms to the total number of atoms present in the sample, means whenever the radioactive substance has taken, the number of atoms present in that radioactive substance, the total sum of the lives of sum of the lives of all the individual atoms by its total number of atoms present in the sample can be called as average life. Also we can say that the time during the number of atoms to become reduces to 1 by e times of its initial number. 1 by e times of its initial number, also we can say that is the also average or mean life. Means if in case of just consider, if the radioactive substance is containing that 100 atoms in that case, so the 100 atoms are having that most of the in the radioactive substance, some of the atoms having the long life, some of the atoms have short life. Means all the atoms does not disintegrate at the same time. Some will take some time to disintegrate, some atoms will be slowed down, some atoms will be disintegrate fastly. Means some of the atoms are having the short lives, some of the atoms are having long life. So that's why the total radioactive substance does not disintegrate at the same time. So that here the atoms are having the 100 atoms are having in a radioactive sample, then their individual lives, some of the individual lives by 100, means number of atoms are present in that substance is 100. So that number of individual lives of total lives of atoms present in the substance by the total number of atoms present in the sample is called as average or mean life. So that is denoted with tau. Tau is equal to 1 by lambda. Lambda we know that is a decay constant. The decay constant means whenever the number of measurement means the decay constant is nothing but the reciprocal of time during which the total radioactive substance decreases to its 37%, then only that can be said as a decay constant. So that the time during which the number of atoms reduces to 1 by e times the initial number. All we know that n not be the number of atoms present at in any instant at t is equal to 0 time, means it initial activity, means the initial time whenever the substance which has taken, that is the number of atoms present in that radioactive substance is n naught. So in that case of average life, we know that n is equal to, from the radioactive formula, n is equal to n naught into e power minus lambda t. This formula is also there. So in that case, if we want to find out tau is equal to 1 by lambda be the average life formula. Average life formula means if in case of lambda taken to this side, then 1 by its average life, it will become 1 by its average life. So here we have the half life is t half which is equal to 0.693 by lambda. From this formula, lambda is equal to, we can write that 0.693 by t half. So by substituting this lambda formula in the average life, average life, that is tau is equal to 1 by lambda, then we can get tau is equal to 1 by 0.693 by t half. T half. So from that case we can write that tau is equal to that is the value for the 1 by 0.693 is which is equal to approximately the value will be 1.44. The 1.44 value will be there. So 1.44 t half means this is the relation between the half life and average life. That will be case of we can write that the average life means that is 1.44 half life, that is tau is equal to 1.44 t half. We from this formula also we can write that is a average life or a mean life which is equal to 1.44 into half life. 1.44 into half life. This is the relation between the average life and half life. Also we can write that is 1.44 into half life, means whenever the half life is t half is equal to 0.693 by lambda, that is lambda is equal to 0.693 by t half, we can write that. But we know that average life is that is tau is equal to 1 by lambda. By substituting this formula 1 by 693 is equal to 1.44, that is whenever the t half is the denominator for denominator, so that's why it will becomes numerator, that is 1.44 into t half. So average life which is equal to 1.44 into half life. Here some of the atoms are having the less short lives, so that's why like like in the case of plutonium and tritium are disintegrated in the nature, so that we can't get in nature. Already a few thousand years ago that tritium and plutonium we can't get naturally. We can develop it in nuclear process. So we can develop in artificial in a nuclear process. So this is about average or mean life. And we know that we have the another method, alternative method for the relation between average life and half life. Average life and half life. Another method also there. From that method, the number of atoms, the total number of lives present at that instant, the total individual numbers can be said that the total number we can write whenever we know that the average life which is equal to the total lifetime of the nuclei is dn. The total lifetime of nuclei which is equal to dn, and the total lifetime of all the number present, all the nuclei present initially in the sample, means the total all the nuclei present at an instant that is which is equal to at an instant which is equal to integral instant in sample which is equal to integral up to 0 to infinity. We don't know that and that is time has taken that the t into dn, the total lifetime, the t into dn, so that here we can write so from that equation we can write that according to the average life definition, that is tau is equal to 1 by lambda and 1 by lambda. From that relation we can write that from the definition of average life, that is tau is equal to, we know that the number of average lives is here, the individual, the total according to the sum of the lives of all individual atoms. This is the sum of the lives of all individual atoms. So that's why we are writing that t into dn from 0 to infinity by next the total number of atoms present in the sample. The total number of atoms has taken that n naught, so that is n naught. But we know that n is equal to n naught into e power minus lambda t. Minus lambda t. From this relation we can write that if in case dn is equal to, by differentiating this equation, then we can get that n naught into lambda becomes lambda into e power minus lambda t. E power minus lambda t. So here dn is equal to n naught into lambda. Here we are writing that lambda into e power minus lambda t. If we are substituting in this equation, then we can get that tau is equal to integral 0 to infinity, that is a t into n naught into lambda into e power minus lambda t by n naught. So from this relation we can write that here n naught with the constant same, it will not change the number of substances, so that's why n naught get cancelled, then lambda will be the decay constant. So that we are writing that here lambda and n naught taken outside, lambda n naught integral 0 to infinity t into e power lambda t minus lambda t dt. Then from that here we are writing that by n naught, that n naught get cancelled, then lambda will be remains. So tau is equal to lambda into integral 0 to infinity t into e power minus lambda t dt. So we have the formula for integral formula, that is integral f of x g of x dx, which is equal to f of x integral g of x dx minus integral f dash of x internal integral g of x dx into dx. That is the formula. By applying the formula in the equation, then we can get some equations. Let's do the problem. Formula is integral f of x g of x dx, which is equal to f of x into integral g of x dx minus integral f dash of x internal integral g of x dx into dx. So this is the mathematical integral formula for we are applying in the tau is equal to lambda into integral 0 to infinity is the limit t into e power minus lambda t dt. In terms of t we are integrating. So this is the formula, you should remember this one. So that this is the alternative method for the relation between the average life and half life. So by applying that, again I am writing the same equation, that is lambda into integral 0 to infinity t into e power minus lambda t dt. Consider t is the f of x and e by t is the g of x. So by considering both f of x dx, by applying the formula, then we can get that is tau is equal to lambda into f of x means t into integral g of x dx means integral e power minus lambda t means integral e power minus lambda t dt, that is equal to, we can get this from the equation e power minus lambda t by minus lambda, e power minus lambda t by minus lambda. So e power minus lambda t by minus lambda, integrating on that one. Next, from this equation again minus integral f dash x, integral between the limits 0 to infinity, it is also 0 to infinity between the limits, integral f dash x. F dash x means already we know that t, f dash x means that will becomes 1 because of dt, t dt, then f dash x dt by dt, that will be 1, d by dt of t, that will be 1. So we are right, I am not writing that. Then here again integral g of x dx. Integral g of x dx will be e power minus lambda t by minus lambda into dt. This is the formula, right? So, if we applied the limits in the equation, then we can get that lambda of this total term becomes 0 because of it is there infinity. If e power minus lambda t can be written as a 1 by the whenever the lambda taken outside, then if the 1 by e power minus lambda t in the place of t, if we write the infinity, then it will becomes a 0. So, total term becomes 0. Even though if the 0 is written, also total term 0. So, total term becomes a 0. Total term becomes because of t into something is there. So, that is why the total term becomes a 0 minus the minus lambda taken to this side, then it will becomes plus 1 by lambda because of its decay constant. So, integral between the limits 0 to infinity, we can get e power minus lambda t dt. So, if the lambda is substituted inside, then lambda, that 0 lambda into 1 by lambda integral, then it will becomes lambda get cancelled. So, that here lambda of 1 by lambda integral 0 to infinity e power minus lambda t dt, lambda get cancelled. From that equation relation we can get that 0 to infinity e power minus lambda t dt. Again we have the same equation, that is integral e power lambda t dt. This is a since value, that is e power minus lambda t by minus lambda between the limits 0 to infinity. So, in that case by applying also same we can get that whenever the lambda is taken outside, means if the infinity is substituted, then minus lambda will comes outside, then if the substitution is there, then 0 if will, here is that, even though if the values are substituted in that case of, then we can get 0 initially, infinity substituted is 0, we can get that, and after that if the substituted 0, e power 0 will becomes 1 minus 0 minus of if 0 is substituted, e power 0 you can consider 1 by lambda minus 1 by lambda, minus lambda is there. So, minus get cancelled, means 0 minus into minus plus, so that is why 0 plus 1 by lambda we can get that. From that relation we can get that tau is equal to 1 by lambda. This is the relation of between the average life. So, this is the relation of average life, that is the proof of average life. From this relation also again same term can be considered, that tau is equal to 1 by lambda, whenever we can get that from the t half is equal to 0.693 by lambda. From that relation lambda is equal to 0.693 by t half. So, from that if we substituted the lambda value in the equation, then we can get tau is equal to 1 by 0.693 by t half, then tau is equal to 1.44 into t half. So, this is a average life which is equal to 1.44 into half life. This is the relation between the half life and average life.